The diagram shows a closed plastic cylinder used for making compost. The radius of the base and the height of the cylinder are R centimetres and H centimetres respectively, and the surface area of the cylinder is equal to 30,000 centimetres squared. We need to show the volume can be given as 15,000 R minus pi R cubed. So the volume of a cylinder, I know that is the area of the circle times the height. I'm told about the surface area. So the surface area is the area of the two circles, the circle on the bottom and the circle on the top. So 2 times pi r squared plus the area of the rectangle that wraps around them. The height of that rectangle is h, and the width of that rectangle is the circumference of the circle. So therefore its area is 2 pi r h. And we were told that the surface area was 30,000. Right, what I'm going to do, considering this is what I want to show, and I want to turn this into this, notice that I want to replace the h. I've got a h here and there's no h here. So what I'm going to do is I'm going to rearrange this equation to make the h the subject, so I can substitute it in here. Now, first thing I'm going to do, just to make my life a little bit easier, I'm going to divide this through by 2. I'm going to subtract the pi r squared from both sides. And dividing both sides by pi r. So h is equal to 15,000 minus pi r squared over pi r. I can now substitute this in instead of my h here. So pi r squared times 15,000 minus pi r squared over pi r. Now, if I were to multiply through now, the pi here is going to cancel with the pi on the bottom there, and the r here is going to cancel one of those r's there. So I will just get r times 15,000 minus pi r squared, which is 15,000 r minus pi r cubed. And that's what we needed to show. We're then told to find the maximum volume of the cylinder. Now we know the maximum occurs when the gradient is equal to 0, so we're going to differentiate this. The 15,000 r will differentiate to be 15,000. The pi r cubed will differentiate to be 3 pi r squared. And that has to equal 0. Add the 3 pi r squared to both sides. Divide by 3. Divide by pi. And square root . Which gives the radius, when there's a maximum volume, as 39.89. So that's the value of the radius that gives the maximum volume. To get the maximum volume, I'm going to substitute R back into the equation here to work out the maximum volume. So Vmax is equal to 15,000 times the 39.89 minus the pi times 39.89 cubed, which gives 399,000 to three significant figures. I don't think I need to be more accurate than that. 399,000 to three significant figures. I've rounded that. The actual number on your calculator displays should be 398,942. But to three significant figures or nearest 1,000, it's that. Last bit of the question, we do need to show that this is actually a maximum. So to do that, we're going to differentiate for the second time. So differentiating this again, the 15,000 will differentiate to be 0. The minus 3 pi r squared will differentiate to be minus 6 pi r. And when r is the 39.89, if I substitute that in, minus 6 pi times the 39.89, we get minus 751.9, which is less than 0, therefore a maximum. And we're done.